there. So this is review number 6, rational expressions. And before we begin, we're going to review what domain is. So the domain is what values can I put in for x and still get out values for y? What can I input to get an output? So if you look at example A, you'll notice that I can put any number in for x in the numerator because it's okay if the numerator is 0. 0 divided by a number is 0. But if you look at the denominator, we have two things we have to consider. Item number 1 is the denominator cannot equal 0. Item number 2 is because it's a square root, I have to have a positive number that comes out of the square root. We know that the square root of a -4 is imaginary. Remember, it's 2i. And so to make this real, my domain has to be 2x plus 3 is greater than 0. So that's really important, this setup. I can't put it greater than or equal to, it just has to be greater than. Subtract 3 to both sides, divide by 2, and x is greater than -3 halves. So the domain in interval notation is going to start at -3 halves, but don't include it, so that's why there's a parenthesis, and it's going to go to infinity. Looking at B. On B, you can plug anything you want in for x and still get an output. So your domain is -infinity to infinity. And the last one is C. We have to consider that the denominator cannot equal 0. So you can see the setup right here. I put x squared subtract 49 is not equal to 0. Because we know if that was equal to 0, 7 over 0 is undefined. To figure out what x cannot be then, we just factor x plus 7, x minus 7, difference of 2 squares. And then we would say x is not equal to -7 and x is not equal to +7. Writing in interval notation can be a little bit tricky. You have to start at -infinity and then you have to stop at -7 because you cannot include it. So you have the parenthesis. The U stands for union and then parenthesis again. You're going to pick up at -7. So this is how you not include -7. And then you're going to stop at 7, parenthesis, don't include the 7, union, and then pick up at 7 again, parenthesis, 7, and go to infinity. Looking at example 1, it just wants us to say if it's a rational expression. To determine if it's a rational expression, you look at the numerator first and determine if it's a polynomial. And then you look at the denominator and determine if that is a polynomial. If the numerator and the denominator are both polynomials, then yes, it's a rational expression. Now, as a reminder, what is a polynomial? I put that in the Cornell. So a polynomial is going to be terms connected with add and subtract. So 2x cubed is a term, x is a term, and 5 is a term, and it's connected with add and subtract signs. Now, the other condition of a polynomial is the variables exponents have to be whole numbers. So I always think of whole numbers as start with a donut hole, which is 0, and then count 1, 2, 3, and so forth. No decimals, no fractions. So for example, 3xy to the -2nd power is not a polynomial because of the y to the -2. Another one that's not a polynomial is 2 over x plus 2. So that is not a polynomial. So if we look at the first example, it's not a polynomial because the square root is the same thing as x to the 1/2 power. So 1/2 is not a whole number, so therefore it's not a polynomial, and we will say it's not a rational expression. Now B you look at the numerator and the denominator separately. So if the numerator is a polynomial, yes it is. The denominator is a polynomial, yes it is. And so since the numerator and denominators, looking at them separately, are both polynomials, we would say yes, this is a rational expression. Again, it's an expression, not an equation, because there's no equal sign. Looking at example 2, we're just trying to make the two sides equal. So if you look at this fraction, we want it to be proportional to this fraction, which means we have to figure out what to put in for the question mark. So looking at the denominator first, you see this is 7x, and you need to figure out how do I change that 7x into a 28x to the 4th? Well, I would have to multiply it by 4x cubed. So then you're going to multiply the numerator by 4x cubed, and in place of the question mark is 4x cubed times 5x plus 1. And that's going to be the fraction that would be equal. You can see I simplified the numerator by taking the 4x cubed and distributing it through the parentheses, which gives me 20x to the 4th plus 4x cubed. This is a cube, it's hard to read. All over 28x to the 4th. Looking at B. So B, how I figured out the question mark is I started by factoring. So you can see on the top, an x came out, and it factors as x times 2x subtract 3. And the bottom factors as 6x plus 5 times 2x subtract 3. So looking at this, you can see that these will cancel, giving me x equals x over 6x plus 5. I factored the 12x squared subtract 8x subtract 15 by guess and check. So I guessed the first times first, I guessed the last times last, and I checked it to make sure that negative 18x plus 10x is going to give me the middle term, negative 8x. Later on, I'm going to go into more methods in how to factor, especially when a is not equal to 1. But before we do that, I need to remind you about the difference of cubes. So if you have a cubed subtract b cubed, this is called the difference of cubes. You are going to need to memorize how to factor the difference of cubes. So to factor it, it's a subtract b times a squared plus ab plus b squared. Now, one way you can remember the signs is the subtraction is going to always be the same as the original problem. So I put an S here for same. Then the next sign is going to be the opposite. So if this is a subtract, this is a plus. And then the last sign is going to be always positive. This is what I call SOAP. This is an S. S-O-A-P. The last sign is always positive. Looking at example 3, we're going to reduce the rational expression. The first thing we do is we begin by factoring. So I factored the numerator. It's a difference of 2 squares, and at the end of this video, I'll review how to do difference of 2 squares. Example 3a, we're going to reduce the rational expression. We do this by factoring the numerator and the denominator first. So the numerator is a difference of 2 squares. X squared is a perfect square, it's x times x, and 4 is a perfect square, it's 2 times 2, and it's connected by a subtraction sign. This is a difference of 2 squares. In the Cornell, I wrote how you factor that. It's a plus b and a minus b. If you're wondering what a and b are, the x is the a and the 2 is the b. It's the number that you're squaring. So it factors as x plus 2x minus 2. On the bottom, we have what's called a perfect squared trinomial, and it ends up factoring as x plus 2, x plus 2. Quick review on factoring. When a is 1, it's multiply to get the last number, which is 4, and it's add to get the middle number, which is 4. And so our numbers are 2 times 2, x plus 2, x plus 2. Now before you cancel, you're going to state the restrictions. The restrictions with rational expressions are anything that's going to make the denominator 0. So if I were to put a negative 2 in for x, I would get negative 2 plus 2, and that's 0. And then 0 times anything is 0. So x cannot equal negative 2. That is the restriction of the domain. And then lastly, we can take the x plus 2 and the x plus 2. We can cancel it, and my final answer is x subtract 2 over x plus 2. Example 3b, when we factor the denominator, it's a difference of cubes. So let me slide this down. Difference of cubes. So we know x cubed is a perfect cube, x times x times x. And 27 is a perfect cube. It's 3 times 3 times 3. So if you're wondering what the a and b are, the a is x and the b is 3. The a and b are always the numbers that you cube. So x times x times x and 3 times 3 times 3 is 27. Now, because this is subtract, this will also be subtract. So I call that same. Because this is add, this is going to be the opposite. So if this is subtract, this will be add. So opposite. And the last one is always positive. So that's the SOAP. Now, this is going to be a subtract b, a is x, and b is 3. So that's x minus 3. A squared, so x squared, plus a times b. A times b is 3x, and then plus b squared. B is 3, remember, so 3 squared is 9. So when you factor a difference of cubes, this second part, this quadratic factor, is going to always be imaginary. So you'll never be able to factor this part out again. But looking at this then, we're going to state the restrictions. So we can't have a 3 because 3 subtract 3 is 0. So x can't be 3. And then you don't worry about this part because it's imaginary. All right, and then our final answer. So we stated our restrictions, which was number 2. And then number 3 is we go ahead and put our correct answer. So our correct answer for this problem is going to be 1 over x subtract 3, and that's because the numerator and the denominator here canceled. Remember that when you're canceling, just a quick reminder, we have to cancel this entire quadratic factor. So these have to be identical. So for example, look over on example 3a. You can't just cancel the x's because this is a binomial. It's connected, x subtract 2 and x plus 2 are connected. And so the only way you can cancel, like I did here, is when they're identical. And I'll have to get your feedback with the Elmo if you're liking me explaining and having it written out, or if you prefer for me to write it out and explain as I go. I'm not sure what you will like the best, but I thought I'd try it this way to mix things up. Okay, numerator. I factored the numerator and I got 5x subtract 7 and 2x plus 1. I factored the denominator, difference of squares, 2x minus 1, 2x plus 1. Before you cancel, you always state the restrictions. So the restrictions, If you're not sure what's going to make this go to 0, then just put it equal to 0. So if I put it equal to 0, I get positive 1/2 because I add the 1 and divide by 2. If I put this part equal to 0, I subtract the 1 and divide by 2, which gives me the negative 1/2. So that's my restriction. These two numbers would make my denominator go to 0. After that, then I'm ready to go ahead and cancel. So you can see that this factor and this factor will cancel. And my final answer is 5x subtract 7 over 2x minus 1. Next, I want to review factoring really quickly. So if you remember how to factor, you can definitely fast forward this. I wanted to show you how A is not 1, it's 10, and C is negative 7. And I'm going to show you the AC method. Now, there's lots of methods with factoring. You could split the middle, but I really do like this method because it's quick and easy. So A times C is negative 70, and then the middle term is negative 9. And we have to think of two numbers. We can multiply to get negative 70, but add to get negative 9. If you can't think of the numbers, just start listing. So I could do 7 times 10, and one of those would have to be negative, so that when I add, but I'm trying to get negative 9, and so that's not going to work. I could do 2 times 35, and we know that won't work. I know it ends in 0, so how about trying 5? So 5 times 14, and the 14 negative. That's my winning pair. So if you can't think of the two numbers, just start listing factors. I could have even listed those factors in order. So this is 5 and 14, and the 14 is negative, so that when I add these two numbers, I get a negative 9. So with factoring, the AC method is I'm going to actually write this as 10x times 10x. And you might be thinking, well, 10x times 10x does not give me 10x squared. So basically what I'm doing is I'm factoring out a 1/10. And so now what I'm going to do is my two numbers are 5 and negative 14. And what's going to happen now is when you multiply this back through, either both of these are going to reduce, or at least one of them will always reduce. So what I'm going to do, and I'm going to cross this 1/10 out as I bring this through, is I'm going to divide both of these by 5. And I know that these can both be divided by 2. And then that's going to give me 5 goes into 10 twice, so that's 2x plus 1. And 2 goes into 10x5, x minus 7. So again, either one will always reduce or both. And now I can check it. First things first. So I've got 2x times 5x is 10x squared. My outsides and my insides have to equal my middle. So negative 14x plus 5x is negative 9x. And then my last times last gives me last. So 1 times negative 7 is negative 7. So I was able to factor that, and that's what I used in the prior problem. So I will let you look at example 4, A and B, but basically you can do this in 3 steps. You factor first, you state your restrictions, and then you divide out common factors. So common factors, not terms, means that when I cancel, I have to cancel the entire binomial. So t plus 3 cancels with t plus 3, and t plus 2 cancels with t plus 2, and t minus 3 is not going to cancel with t plus 3, nor will it cancel with t minus 2. When you cancel, you always cancel by levels. So you can cancel diagonal up and down, or straight up and down, but you can't cancel straight across. So it's always top to bottom that you cancel. I'm looking at this. I got t subtract 3 over t squared plus t subtract 6. Example 4b, something I wanted to point out is because this is divide, you're going to do keep, flip, change. So you're going to need to keep the difference of cubes, and I put SOAP up here again for you. And how you know you have a difference of cubes is y times y is y cubed, and 2 times 2 is 4, times 2 is 8. So those are perfect cubes. So in this formula, the y is the a, and the b is the 2, the perfect cube. So it factors as y minus 2 times y squared plus 2y plus 4. Looking at this, because of the divide, it's keep it, flip it, and then change it to multiply. So you keep, flip, change, and then you just start canceling. Notice that this 2 is going to cancel with this 4 and become a 2 that's left. And then if this is y cubed, one of those y's cancels, so it's y squared with that y. Now, if there's no add or subtracts, these just cancel. But if there's adds and subtracts in between, you have to cancel the entire binomial. So y minus 2 cancels with y minus 2. And I believe this gives me 2y squared plus 4y plus 8 over y cubed subtract 3y squared. And you can stop the video and look at the work. So example 5, there's something that is really important here. And this is when you see 5 subtract x in the bottom. So 5 subtract x is the same thing as negative x plus 5. Look at how I just changed the order. The 5 is positive, it's still positive. The negative x is negative. I changed the order of the two numbers. Now, if I factor out a negative here, then I have negative times x subtract 5. And that's going to be important because if I change how this looks, then when I factor the numerator, the x minus 5's will cancel. Now, no one likes a negative in the denominator, so the negative in the denominator can be moved up to the numerator, which is what I did here, and then I distributed it. One thing to note, over here, I practiced the AC method again. So quickly, I took 3 times negative 20 is negative 60. Negative 11 was the middle number. The two numbers I needed were negative 15 and 4. So then I had 3x minus 15 and 3x plus 4. Now, of course, 3x times 3x is not 3x squared. This is why I factored out the third. Now, when I take the third and I divide it or multiply it back through, so I divide by 3, you're going to see that 3 goes into 3 once, so that's x, subtract, 3 goes into 15 5 times. Nothing reduced here. So sometimes both of these reduce and sometimes just one of them reduces. But one will always reduce when you use the AC method. So that's example number 5. Example 5b, I'm going to let you just go ahead and look at the work, and if you have questions on it, let me know. And I'm going to work out for you example 6a and b using my Smart Notebook. Example 6a, I want you to be really, really careful with the subtraction sign right here. So what I recommend is change the subtraction to plus the opposite. And that's going to help you with that subtraction sign. So when you are adding, you need to have a common denominator. So to get a common denominator of these two fractions, the common denominator is x plus 4 and x subtract 2. Now, the first fraction is missing the x subtract 2. So you multiply the top and bottom by x subtract 2. The second fraction is missing the x plus 4. So you multiply the top and bottom by x plus 4. Now what we're going to do is x minus 2 times x minus 3 is going to be FOIL. First, outer, inner, last. First things first is x squared. a negative 3x and a negative 2x is a negative 5x. And then negative 2 times negative 3 is positive 6. Now you have the subtract here, subtract x, which has to be distributed. So that gives me a subtract x squared, because x times x is x squared, and a negative x times 4 is a negative 4x. Canceling what you can in the numerator, so the x squareds are going to cancel, and then a negative 5x and a negative 4x is a negative 9x. So we have 6 subtract 9x. A lot of times they'll put the 9x second since it is negative. And then that's going to be over. And then you've got let's see, now the bottom is x squared. Outside insides is plus 2x. And then last times last is subtract 8. Example 6b, last example. Again, I worry about the subtraction in the middle getting lost, so I do recommend writing this as plus the opposite. So now what we're going to do is we're going to factor everything. When I factor 2x squared subtract 7x plus 6, here's another method. Because this is a really simple quadratic equation, you might just want to do guess and check. 2x times x is 2x squared. We need to get a positive 6. So you can try some numbers and then erase if you need to. Notice this gives me a 6x and a 2x, and that's not going to work. So let's switch those two numbers. So I'm just erasing these two numbers, and this is why it's called guess and check. And I'll try putting a 3 here and a 2 here. Now this is a 4x and a 3x, and if they are both negative, then I will get the negative 7x, and then negative 3 times negative 2 is positive 6. So I just did guess and check. So the next thing you're going to want to do is cancel anything that will cancel. So remember, it's top and bottom, so the x plus 1 will cancel with the x plus 1. You cannot cancel the x minus 2's because they're on the same level. So you are pretty much done now. You have this equals a negative x, and on the bottom, you have 2 of those x subtract 2's. So you can write them out twice or just put a square. And then you have a 2x subtract 3. And that's it. For the reflection, you can put anything you want. You may want to write soap and see if you can remember the difference of cubes.